you can divide your reactions, your half reactions, right? So write your reduction reaction, write your oxidation reaction. All right, so let's go ahead and divide those up. All right, so I'll talk about this bad boy here. PH plus aqueous plus 6 electrons goes to 2, CRP plus aqueous plus 7. Okay, so it's 1/2 reaction. We go ahead and write matter. Okay, so I've written my half reactions. Now I need to figure out what's my anode and what's my cathode. I got to figure out what I'm going to subtract when I go back and look at my reduction potentials. All right, so what's being reduced here? What element's being reduced? The chromium's being reduced, all right? So this is being reduced. So is this my anode or my cathode? Cathode. All right, iodine's being oxidized, so what do we call it? The anode. I know this sounds ridiculous that I keep making you say this over and over, but on exams, people flip these all the time. And I think that there's some class in the physics department that teaches them. I was talking to another colleague of mine, they actually teach them flipped. So anyway, all right, so we've identified our cathode and our anode. All right, so now we can use our equation here. We can calculate our standard cell potential by taking our standard reduction potential of our cathode, which is 1.33. All right, and I'm going to subtract the standard reduction potential of my anode, right? It's being oxidized, so we have to, subtract it because we're like saying it's flipped around, right? So here, look, this is the opposite of the kind of reaction that we have here. So I'm going to subtract 0.54, and I get 0.79 volts. One of the few places where you can just ignore stoichiometry. It doesn't matter. It's convenient. Okay? So our standard cell potential in this case, and again, standard cell potential is assuming that everything's 1 molar, that we're at 25 degrees Celsius, that everything's under 1 atmosphere of pressure, is 0.79 volts. Our units here are volts. Okay? All right, sweet. Now we got one more place to go with this. We got one more place to take this, and then we'll be done for electrochemistry. The place that we want to go is relating this idea, right? We're going to relate our cell potentials. We're going to relate cell potentials now to free energy. We're going to come back to delta G, that third great lecture, that third great idea that we have in chemistry, right? Delta G can be thought about as a measure of whether or not a reaction is spontaneous, right? Whether or not something is thermodynamically favorable, or whether or not something is spontaneous. If you have a cell, and that particular cell has got a positive EMF, then it's a spontaneous process, which makes sense, right? I mean, think about, let's go back to this picture. Right? If this is positive, that means that this is happening. All right? And it's going to be as spontaneous as water flowing over a waterfall. So positive E, spontaneous process. Negative E, non-spontaneous process. Now, of course, as chemists, we can come up with a way to quantify anything. And so we have found a way to quantify delta G for redox reactions. If we want to figure out if a redox reaction is spontaneous or not, we need to use this equation. Delta G equals negative N times F times E, where N is our number of moles of electrons transferred. So here we do have to look at stoichiometry a little bit. How many moles of electrons would be transferred in this reaction? What's the coefficient in front of E? 6, okay? So we have to find number of moles of electrons. E is just our EMF. And F is our special new constant called the Faraday. All right? And this is the version of the Faraday you're going to see most often. All right? These units at least. Okay? Now, if we want to look at delta G under standard conditions, and again, right now we are still in standard condition land. We have not moved from concentrations of 1 molar or temperatures of 25. We are firmly there. We can use this process to find our standard delta G. So we have a new way now of finding out standard delta G if we're dealing with a redox reaction. So I would like you guys to try this. Ooh, there we go. I would like you guys to try. I'm going to give you a reaction, and I want you to tell me what is delta G. All right, here's your reaction. And notice that it's not a half reaction because you're not going to see half reactions on exams. Okay. All right, here's your overall reaction. What you need to do is the same thing that you did in the last problem. Divide it up into half reactions. Figure out what's at the anode, what's at the cathode. Find your EMF here, find your standard cell potential, and then you should be able to solve the problem. So I'll go ahead and write this down that a Faraday 96485 joules moles. And I'll go ahead and put that list back up here. Just make sure that we've got everything. Yep. And good. And then try to solve this one on your own.